Again, those who aren't talking are more likely to call on.
Success will be greater than 10. And then X would be 3.
We're talking to him.
Yeah.
All right, so Seth, what's my N?
10.
10. 10 people are selected at random. That's my N. Okay. Ina, what's my X? How many successes do I want? So that's the probability you're trying to find. You're trying to find the probability of exactly 3. All right, so I want exactly 3 successes. That's the probability I'm trying to find. What's my little p? This is the one that's a little tricky for folks. What's little p? What's the probability I pick somebody and they visited a doctor? So that's something I'm giving you. It doesn't change. It's something that's a statement that's given to you. What's the probability I pick somebody and they have gone to a doctor? Amna, what'd you guys get? What'd you folks get? 50% chance? So is it equally likely that you did or you didn't? Are they, is it?
Is it 0.2?
Okay, so we have a 3 out of 10 and we have a 0.2. All right, so let's look at that. If it's 3 out of 10, why would people think it's 3 out of 10? Because people are thinking that exactly 3 out of the 10 people. So here's the problem with that. So then what's the probability that 10 people, I asked 10 people and all 10 of them have visited a doctor that month? Then that probably would be 10 out of 10? 100%? Does that make sense that you got 10 people and the probability that they all went to a doctor is 100%? So that can't be. So I'm not trying to, so look for what you're given, what actually has happened. Not what you're trying to find, but what has actually happened. So Sarah, where'd you get your 0.2 from?
Because 1 out of 5, the survey said that was 1 out of 5 Americans say that they visited a doctor, so 1/5 is 0.2.
Right, so this exists before your experiment. Right, before your experiment even came along, there was a survey. Before you even thought of your experiment, this existed. 1 out of 5. A survey found that 1 out of 5 Americans visited a doctor. Survey kind of said. So think of the little p as being out there in the world. It's for the whole world. It's like what's probably I flip a coin and the probability is heads. The 50%. It will not change if I say, what's the probability that I flip a coin 10 times and I get 3 heads? Is that 30%? No, right? Because every little p is 50% no matter what. Is everybody with me on this part? So little p, that's already out there in the world. It's kind of the universal, probability out there. Has nothing to do with your little experiment. So that's the 1 out of 5. Everybody feeling all right with that better? Yeah. Okay. So now we're going to plug all those things in. So 10, choose 3. Aha. So 10, choose 3. Let's hop over to our 10, choose 3. Hop over to our calculators. Turn them on. Clear. Everybody have your calculators? I want 10, choose 3. Everybody type in 10 first. I want 10. So get a 10 in there right away. Everybody has a 10 in your calculator? Yes? Okay, and then I want choose. So you're going to hit math, which is the third one down on the left. Everybody hit math. And then go over to probability. All the way to the end. Probability. And then in the probability, you see the NCR? Everyone see the NCR? The third one down? So you can hit arrow down to it or hit 3 either way, and you'll get the NCR. Hit enter. And when so that gives you 10 choose. What do I want? 10 choose what? 3. What did you get when you did it?
120.
120. Good? So now that on the last exam you've proven to me you understand how to find 10C, N choose X, you do not have to do it anymore like that. You can just use a calculator and do NCR instead. Everybody all right? Good? Okay, so we found that this is 120. And then we're going to do 1/5 or 0.2, we'll call it 0.2. Raised to the, how many successes do I want? 3. And a probability of failure, 0.8, raised to how many of those? 7 of those. And you'll get 0.201. Another way of looking at this is to think of it as I have 10, I have success, 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 fail, 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 one more, fail. And so that's one way of getting, on the tree of getting 3 successes and 8 failures. Sorry, 7 failures. Whoops, my bad. Only 7 of them. And this is 0.2 to the 3rd power times 0.8 to the 7th power. Everybody with me on that part? And then the 120 tells me how many ways can I take 3 S's and 7 F's and rearrange them. So that's where that 120 comes from. There's 120 ways of rearranging 3 S's throughout these 10 spots. Okay. I think we're good, right? And just as a reminder, because people kind of start thinking that they grab that exactly 3 out of 10, and they think that 3 out of 10 is the probability. We're not saying we actually found 3 out of 10. We're saying we want to know what would be the probability if I picked 10 people of getting 3. So we aren't saying 3 out of 10 did happen. We're saying we want to know the probability that it might happen in the future. Do you see what I'm saying? So what we do know is in the past, it's 1 out of 5. That's what we know. We did it over and over. They did a big survey. They found 1 out of 5. So that's kind of what you have to kind of bear in mind. All right, so here's an example. We're going to find the probability of x. So it's n. So you can write it either way. They're the same thing, because that's n factorial over n minus x factorial x factorial. That's just n choose x. So I don't like this one, but if you are comfortable with it, you can use it. I don't care. They're the same thing. They're identical. I like this one better. So this would be 5 choose 3 times, let's see, little p is 0.
I mean, you could just do it on a calculator like that. So you just do 15 times on here. You could do 15 and then you find that.
Working on lab problem 6.
Now that I know what to do in the calculator, I forgot what
Okay, so again, this is what I need on the exam. I need just this part down below. Right? The 5 choose 3 times whatever to the 3rd times whatever to the number of failures you have, and then your answer. So for you folks, what you have is the first one. You have 6 of them. You're going to choose 4 times 0.03 to the, how many successes do I have?
4.
So 4. So 0.03 chance of success raised to the number of successes times the probability of failure. What's probability of failure for one little guy? Yep, 0.97. How many failures do you want to have? 2. Yep. 4 successes, 2 failures. What did you folks get for that one?
Yeah.
0.000. Give another decimal after that.
Oh, yeah, 1.
1, 1?
Yeah.
What's up with that?
And a 4.
4? Okay, so now we're getting into some smaller numbers. Everyone, hey guys, with me. Give me 3 sig figs. So go to your first non-zero and then give me three numbers after you get to your first non-zero. We'll talk about sig figs more next week, I think. All right, next one was 4, choose 1 times, my probability of success is 0.18. How many successes do I want? 1. My probability of failure is 0.72, right? My little q is 1 minus 0.18. So 0.82. My bad. 82. Raised to the value of, if I have 1 success out of 4, how many failures do I have? 3. So what did you folks get for that answer? Jake, I can't hear you.
0.39698.
698. So 397 if you round to 3 decimals. Good? Run 3 6 Okay. All right, let's take a look at a word problem. Survey, why am I reading? And doing the repeat.
A survey from Teenage Research Unlimited found that 30% of teenagers have part-time jobs. If 5 teenagers are selected at random, 5 probability that at least 3 of them will have part-time jobs.
Right, so probability X is 3 or more. So first, figure out my random variable. What changes along here? How many successes can I have? Well, I've got 5 teenagers, so my number of teenagers that are success. What does success mean? Have a part-time job. So my X is going to be the number of teenagers who have a part-time job. All right, what's my N? 5. 5 teenagers are selected at random. That's my N. What's my X? What's my little p? 0.3. Little p is 0.3, 30% of teenagers. That's my little p. Everybody on board? 0.3, 30%. 30%, so 0.3. All right, what does probability of at least 3 mean? If I have at least $3, that means I have how many dollars? $3 or more. So at least 3 successes means that means a probability of 3 or 4 or 5. Or we what? Add. So we're going to find all 3 probabilities and add them. That's exactly what happens. Right? So you find the probability. I'm going to redo this. No, sorry. I'm going to do, this would be 5, choose 3, times 0.3 to the third, times 0.7 to the second. 5, choose 4, times 0.3 to the fourth, times 0.7 to the 1. 5, choose 5, times 0.3 to the fifth, times 0.70 to the 0. Note the things that change. The only things that change are these guys. That's it. Those are the only things that change, each one. Everything else stays the same. So the N, choose part stays the same. The little p and the little q change stay the same. The only thing that changes above is the x, which means that the x and the n minus x change. So those are the only things that change each time. We change as your x's change. Just those pieces change. So I'll find these 3 probabilities, and because they're ORed, I'll add them up. All right, good. So next class we'll start in on yours, but I do want to ask you at least a couple questions about it. First off is, this research found that 40% of Americans do not think that having a college education is important to succeed. A random sample of 5 Americans is selected. Find the probabilities. So my question is, what's my N? what's my little p? So before you leave, find those two things for me, n and little p. What's n? 5. Sample of 5. What's my little p? Yep, 40%. 0.4. All right, good. I'll see you guys on Thursday.
No,